Today I'd like to talk to you about piecewise defined functions. A piecewise function is a function in which more than one formula is used to define the output. So each formula has its own domain. And it looks like this. So you'll see f of x equals, and then this curly brace. So this is formula 1 if x is in domain 1. This would be formula 2 if x is in domain 2. And then, so you need at least two formulas for piecewise, but it can have anywhere from 2 to some other discrete amount, so some other countable amount of formulas. And the domain of this function, f of x, it'll be the union, which is symbolized with this, like it's a capital U sort of. It stands for union. So it's the domain, or the domain is the union, so the combination of all the smaller domains. Okay, so the domain for this function is domain 1 and domain 2 and domain 3 all together become the domain of f of x. So for this formula down here, for this function down here, the domain will be, well, right here, if x is a number less than or equal to 1. So this goes from negative infinity to 1 inclusive. And then this one goes from 1 to 2, include 2. And then this last one is anything bigger than 2, so 2 to infinity. So when I combine all of those, I see every single value is represented, right? Any number up to 1, but 1 is included in this domain. 1 cannot be included in this domain because it was here. So any number between 1 and 2 is, and including 2, is included in this domain. So that's from negative infinity to 2. Well, anything bigger than 2 is also in this domain here. So the domain of this f of x, its final domain, is negative infinity to positive infinity. Right? Every single value will be included. So how do we graph something like this f of x? So let's do each piece individually. Let's graph y equals x squared. So I'm going to do it right here. Let's graph y equals x squared. All right, so a table of values will be, it might look something like this. When x is negative 2, y is positive 4. Negative 1, 1. At negative 1/2, it'll be 1/4. So it'll look sort of like this. And then again at 0, it'll be 0. At 1/2, it'll be 1/4. 1, 1, 2, 4, 3, 9, which falls off the page. You see a graph that looks like this. All right, it's a graph of y equals x squared. So y equals 3, that's this portion right here, right? And that's just a horizontal line, y equals 3. And finally, the graph y equals x is the identity function. You put in 0, you get out 0, put in 1, you get out 1, 2, 2, 3, 3, 4, 4, 5, 5, and negatives as well. Negative 1, negative 1, negative 2, negative 2, etc. right? So I get this straight line here, right? So how do I combine those together to make the graph of f of x? So what I'm going to do is I'm going to cut out each of these individually, and then I'll be back with you. Okay, so here we go. I've cut out each individual graph. This is the graph y equals x squared. This is the graph y equals x. This is the graph y equals 3. So to make f of x, what we're going to do is we are going to use x squared if x is any number less than or equal to 1. So that means I only need the graph, this graph, when x is less than or equal to 1. So I'm going to cut it here at just barely above 1. So I don't need this portion of the graph. This portion of the graph is values bigger than 1. All right, anything bigger than 1, I don't need it. I'm going to get rid of it. All right, so then let's glue this portion down. All right, so here we go. All right, now this next part, we're going to use this graph, y equals 3, only between the values 1 and 2 including 2. So I'm just going to cut this graph at 1. Get rid of this half because this is everything less than 1. Don't need it. And 2. Cut it here just at or above 2, just barely. Because 2 is the cutoff for this graph. So all I need is this little tiny strip. All right, so that's going to get glued down. It's going to get glued down here. All right, the next thing we're going to graph, and the next piece is x bigger than 2. So I'm going to cut off again at 2. This y equals x graph. And I don't need this portion because this is x is less than 2. So throw that away. I'm only going to use this piece where x is bigger than 2. All right. What about the endpoints? 1 belongs to this graph, this parabola graph. So I need an open circle here to begin this graph. 2 is included in this part, so 2, close the circle here, and then open circle here, 2 to positive infinity. That means if f of 1.1 falls into this domain right here, right? Because 1.1 is in between 1 and 2. So f of 1.1 is 3, because that's the output. If x is here, the output is 3. F of 1 itself falls into this bit of the domain. So f of 1, I find it by squaring the value. So 1 squared, which is 1. Right? F of 0 is 0 squared, 0. Right? F of 1/2 is 1/2 squared, which is 1/4. Right? F of 2, again, falls right here in this domain. F of 2 equals 3. Whereas f of 2.1 falls right here, x bigger than 2. So it's just equal 2.1. Right? So that's how we evaluate and graph piecewise functions.